All right, let's analyze a graph using the second derivative test. So this is video 3. Let's analyze f of xy equals y squared minus 2y cosine x. Okay, so let's take the first derivative. Is, well, derivative of this with respect to x is going to be 2y sine x. Derivative of this with respect to y is going to be 2y minus 2 cosine x. Okay, so we have to find when is this 0. So let's look for critical points. Okay, so critical points are when 2y sine x equals 0 and 2y minus 2 cosine x equals 0. Okay, well, here, this is going to be solved when y equals 0 and also when sine of x equals 0. Sine x equals 0 at where x equals 0, x equals pi, x equals 2 pi, x equals n pi. Okay, let's take a look at this thing. Oh, I don't want that. There we go. This is going to be actually on the graph. This is going to be when y equals cosine of x, right? Let's draw that as a graph. Actually, let's do that. Cosine, remember, so that looks like, say, this is 2 pi, pi. Okay, starts at the top, middle, bottom, middle, bottom. Okay, so let's start looking at some of these points. So we're going to just look at one period. That'll give us enough, I think. Okay, so critical points. And we'll say take x between 0 and 2 pi. So if x is 0, okay, well, x0, y0 is going to work, right? So 0, 0 is going to work. Okay. But also we have 0 pi over 2. Hold on. No. Sorry, that's not going to work. But 0, 0 is going to work. Yes. Okay, because if both of these are 0, then let's see. No, that's actually not going to work. My bad. Okay. Y equals 0 makes this thing 0, but y equals 0 does not just automatically make this 0. If x is 0, then this has to be equal to, then to be on this curve, x has to be equal to, sorry. Okay. Starting again from here. So I have it written down. Why do I do so? 0, 1. That's going to be a critical point because when x is 0, then your y has to equal cosine of 0, So that's going to be 1, okay? Pi over 2 is 0 because y equals cosine of x, that's satisfied, but also y equals 0. Also, x equals pi, so pi comma -1, okay? Because there sine of x equals 0 and y equals cosine of pi, okay? 3 pi over 2, 0, that's because y equals cosine of x and y equals 0, okay? And finally, 2 pi comma 1, okay? So that's one full period. Let's take a look at what happens at each of these points, okay? So let's look at the second derivative matrix first. Second derivative matrix. Here, so we're going to take the derivative of this with respect to x is just going to be 2 y cosine of x. Okay. Derivative of this with respect to y is just going to be 2 sine x. Derivative of this with respect to x is going to be what? 2 sine x, which this is a reasonable function, so these two things are the same. And the derivative of that with respect to y is going to be 2. Okay, let's take the determinant of that. So the Hessian is going to be 4y cosine x minus 4 sine squared of x. Okay, so now we're going to go ahead and see what happens to each of these at these different points. Okay, so we can do that, but we can also just look at what does the function do. So let's take a look first at the function, sorry. Okay. What's the value of this function at 0, 1? 0, 1 is going to be what? 1 minus 2 cosine of 0. Cosine of 0 is 1. There's going to be 1 minus 2. It's going to be -1. Okay. How about at pi over 2? Pi over 2 comma 0. Cosine, well, it doesn't really matter because y is 0, so this is going to be 0. Okay. How about at pi comma -1? At pi comma -1, this is going to be, that's 1 squared plus 2, so that's going to be cosine of pi. Cosine of pi is -1. This is going to be 1 minus minus minus, so it's going to be -1 again. Okay. 3 pi over 2 comma 0. This one's going to be, let's see, since y is 0, that's going to be 0. 2 pi comma 1, so 1 cosine of 2 pi is 1, so that's going to be 1 minus 2 is -1. Interesting. Let's actually take a look at the matrix and see what happens. Let's make that a little smaller. There we go. So the matrix here. in this case, what are we going to get? So when x is 0, y is 1. So that means cosine of 1, cosine of 0 is 1, so we're going to get 2. Sine of 0 is 0. So what do we have there? We have a local min. Yes. Let's take a look at pi over 2, 0. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So we're going to get, in this case, we're going to get 0 because y is 0. Sine of pi over 2 is, keep on forgetting, sine of pi over 2 is 1. So we're going to get 2. Okay. 2, 2. Okay, so what happens here? So this thing has a determinant of 0, -4. Okay, so what happens if you have that being negative? Let's take a look again. If this determinant is negative, you have a saddle point. Okay, and actually, you can see, you can do all of these. These are actually all going to basically be the same thing. Here, this is going to be another local min. This is going to be a saddle, another local min. Okay, I wanted to sort of go ahead and let's take a look at this graph. So give me just a second. Okay. So this is the graph. Okay, you can see. So I want to sort of play around with it. You can sort of see that it's really funky looking, right? Okay, but let's see what's going on. Trying, but it doesn't really have a max. It just kind of has saddles and mins. Okay, that's sort of the idea. Oh, that's a good view. Okay, so as you come along here, you have these sort of saddles where it's going in mins. You have mins and then sort of like crazy saddles. Okay, so yes, it does have some crazy stuff. I'm using here, by the way, math3d.org. Just plot it in. You should try it. Okay, try playing around with some of these graphing calculators that are available online. All right, I'll see you in the next video.